Hello interwebs, welcome to Let's Fix Computers. I've got a HP laptop here again, and this is a 15-CS. And I've already taken the back cover off of this one because the back cover was bulging slightly and not wanting to clip down flat. So I thought it was going to have a bulging battery in it, and I wanted to get that out as fast as possible. However, once I took the cover off, I found that the battery just isn't fitted properly. These bottom clips aren't in place. So that means that the battery isn't sitting flat and thus the cover won't close properly. So not a big deal. So the actual fault this laptop has is that apparently it doesn't turn on. So what I'm going to do, let's just do a quick viability or a quick reproduction of the problem. I'm just going to take this battery out in case the battery is problematic or something, because you know someone has been in here before. That's not factory fit. Alright, so that's out. Let's plug this thing in then and see what it does. So I'm going to plug in a HP charger. And whoop. Looks like we're not getting a whole lot of anything there. No charge light or anything. And try and turn it on. Nope. No one at home. No one at home. Alright. Let's unplug that again. Let's do some quick basic stabbing and see if we can see anything screamingly obvious. So I'll put my multimeter into resistance mode. And firstly, we're just going to check for a short circuit across the DC jack. So over on here, let's just punch down a little bit. Over here, the DC jack is in the corner and it's on a fly lead that comes down the side here and plugs in there. So let's just check if there's anything screamingly wrong at the input. So there's 2 red pins, then 2 black pins. So we'll go black and red. And we're seeing mega ohms there, which is extremely high, but that's fine. It's not a short circuit. All right then. So by extension, the TVS diode is here as well. This is going to be fine because that's basically across the input as well, but I'll just check that for posterity, just to sanity check. Yeah, same thing, mega ohms, nothing going on there. Okay, so what I'll do now is I'm going to jump all the way over into the middle of the board to where CPU vCore is. So our CPU is here, we've got a GPU here, and next to our CPU, we've got some bigger power stages. So that's going to be the power supply into the CPU. And this is going to be on the main power rail of the laptop. So we can just very quickly check what the status of that is. So I'll put my black probe on a screw hole again. And there's an input capacitor here. So let's just check that guy. Yeah, we've got 90,000 ohms there, 90 kilo ohms. That seems okay. So it doesn't look like we've got any shorts there. If I move over to this side where we've got more secondary power supplies, just do some quick stabbing over here as well. .66 ohms, okay. Oh, hello. This one's short. 0.22 ohms. Alright, that's probably our issue. What about this guy? 9 kilo ohms. Okay, so up here we've got 2 very similar looking regulators here. These inductors are about the same size, and the MOSFET chip looks about the same on both of them. So there's a good chance that this is our 3.3 volt rail and 5 volt rail. Not sure which one is which yet, but when you see 2 secondary power supplies that look very, very identical to each other, that's probably the 3 volt and 5 volt rail. And we found that one of them is shorted to ground. So that's why this system doesn't power up, because one of those secondary rails is shorted. So what I think we're going to do is we're going to take the motherboard out and start looking a bit deeper into that. What an oddly shaped motherboard. May as well take that out for now. Right, so firstly, any disasters on the back of the board? Nope, not a lot going on there. Let's look again just to see if our short circuit is still where we last saw it. Make sure it hasn't randomly disappeared after taking the laptop out of the chassis. Yep, still a nice 0.2 ohms on whatever that is. Alright, so next question is, can we find a schematic for this so we can find out which rail that one is? Let's have a look. So this is a DA0G7E, and the rest of those numbers and letters. I will type it into Google. Okay, I'm not seeing a schematic around for this one at first blush, but I have found a bad caps thread where someone is also looking for information, and they've identified that the part number for the 5-volt regulator. So let's see if that matches what we're seeing here. Right, these regulators have manufacturing marks written on them instead of part numbers, so that's not going to help me out a lot without doing more research. But there's another way of figuring this out as well. If we go up a bit further, we've got the M.2 port of the motherboard here. And the M.2 port supplies 3.3 volts to the SSD. And that's not necessarily going to come directly off of the 3-volt rail, but it's going to be derived from it. So what I can do here is the top pins here on the inside edge of the connector. So there's the connector itself, and here's the inside edge. Those are 3.3 volts into the SSD. So what I can do is, if I just measure the resistance between the problem, this is the regulator that we're having the problem with. I measure the resistance between those two. So we've got half a kilo ohm there, 593 ohms. And then if I go to the other regulator here, and if we measure there, at this point we've got like kilo ohms and rising. So I can make the reasonable assumption at this point that this guy here is getting its power from here at some point, because we've got a modestly lower resistance to this point. So this is going to be our 3.3 volt regulator. So this method of identifying the 3-volt rail, it kind of sort of works here, but it's not super conclusive or reliable. So if we go back and we look up the part number that I found by doing some Google searching, we actually come up with the Richtech RT6256. And we could probably find this if we Googled those manufacturing codes as well. I just kind of didn't want to do this at the time because manufacturing codes can be a bit of a rabbit hole, so I try to avoid them if I can help it. But this one's actually extremely informative. It leads us to this Richtech 6256. And if we have a look at this, you can see here that we've got a 6 amp 23 volt step down converter, and it is designed to be 3.3 or 5 volt output. And there's two ways that you would set the voltage on a chip like this. The first method is there would be a resistor divider on the feedback pin. So you set the resistances on that feedback pin to set the target voltage of the chip that it goes to. And somewhere in the datasheet there'll be some equations that tell you how to calculate that resistor divider. However, this one is super easy because there's just two different versions of it. As you can see here, there's a B and a C version. And the B is the 3.3 volt and the C is the 5 volt output. And if we roll down a little bit further, you can see on the marking information that the L8 is the B version and the L9 is the C version. So that is the dead giveaway for whether we are looking at the 3 volt or 5 volt one. So if we've got a short on the 3.3 volt regulator, this also means big questions about the PCH. So I'm just going to quickly wipe the paste off of that and just check if there's like a crack in it or anything like that. Well, that looks like a nick on the side of it. That doesn't look good. That's been dinged. So this laptop showed signs of being taken apart before. The battery wasn't in properly. The screws had already been mangled, so they were fighting me every step of the way. And we've got a ding on the side of the PCH. Like, I didn't do that by wiping thermal paste off with a bit of tissue paper. That's not how that works. I'm gonna put a little bit of power into the 3-volt rail because I think that PCH is gonna light up. Okay, so I've got my bench power supply turned on just a probe here, and I'm gonna stab this this spare pad on the output side of the regulator while I point my thermal camera at the PCH, and let's just see what appears. I'm at 1 volt and 2 amps, so nothing vicious. We shouldn't see anything going on with the PCH when we do this, and if we do, then that's really bad. And stab. I've got to reflect. Yeah, there it is. Yes, that PCH is warming up. Let's come in on the macro shot to confirm it. There you go. And you can see there's a big flare up in the corner there. That's dead. That's a shame. So, what happened to this thing? Like, this thermal paste is original. This is the original paste for it. If the thermal paste had been changed, then I would assume that someone repasted this laptop and just completely botched it. But this is the original thermal paste. It's all crusty. So, like, what happened? I mean, unless the PCH failed in such a way that it, like, you know, blew a chunk out the side of it. Wild. Like, that looks like a scrape to me. It doesn't look like a hole burnt out or anything like that. Wild. I don't know. Well, the answer remains the same, folks. Dead PCH is game over. We're done here. I don't know how that happened, but yeah, the evidence is clear. Oh well. Thanks for tuning in, everyone. See you all next time. Bye.